On the S-19, what we did is you get your panel and the plane right here, and as you move back these bulkheads to the second bulkhead after the instrument panel, we used the ledge of the stringer here. We drilled 2 holes, and then we made a crossbar, and didn't have a lot of threads here, so it was one place we cheated a little bit and put Loctite on it. But in any case, the computer is securely attached there. Then we have access to the connector from the bottom, from underneath. If we were to lay upside down, we can get to the connector if we need to disconnect it. We can also get to the port on the side of the computer here for future updates. We also made sure that we strain relieved the cable itself as it leaves the computer, so there's no load on the connector. And we made sure that we screwed these screws in nice and even to pull the connector completely in. And we also verified by looking at the connector that we have an even gap here, so we don't have any problems with a bad connection. We also have our hoses from the manifold pressure 1 and manifold pressure 2, and those are leaving through the large hole that we made in the airplane here. This is going to be covered with a nylon pass-through, a split pass-through from aircraft spruce. And then those 2 hoses also belong with the computer system, and they run out along the engine. They run underneath the intake manifold, and you'll find that they terminate on the throttle body right under here. So you can see them coming out right up in here, one there and one next to it. So those hoses are very important because they tell the computer what the manifold pressure is in the intake manifold, and without that information the engine cannot run. So there's one for computer number 1 and one for computer number 2. Here's the instrument panel in the S9. What we've got is a couple of Dynon screens, and then we installed a throttle cable. And what we did is we had to drill this up just a little bit because the approved throttle cable for the Viking engine is a push-pull cable that uses a fitted end. It has a 1032 thread at the end. It has a lock nut, and the Viking engine comes with a clip for the end. Also very important, back here, the throttle cable clips into a pre-made attached point on the intake manifold. Now, if you were to buy yourself someone else's cable, or off of a flea market, or something that's not from aircraft spruce, you're just asking for headaches. What we'd like you to do is just get the right part number, get the cable with the 1032N friction lock from aircraft spruce. It'll have it'll have a groove in it. This dimple that you see here, super important that actually hits the groove. You have to move the cable back and forth a little bit as you slowly tighten these nuts, and that'll securely attach the cable. Another nice feature about the throttle cable installation that we did here, because we wanted to do the prime example for you of what an installation is supposed to look like to be secure, is that we ordered what is called an eyeball from aircraft spruce as well. And we got the one that was 0.240 inside diameter, and it gives you a secure and nice way of transferring bringing a cable in through the firewall and into the airplane. Now, going back to the instrument panel itself, you see that the Viking wiring bus was installed. This wire bus will change in the near future, but as of right now, it consists of your main switch and your 2 emergency backup switches that are used in conjunction or at the same time. This will be labeled, of course, at a later date. Then it also contains the starter cranking switch with the key. The way this is installed is that underneath it gets mounted to the aircraft, and it is supported in the back here. The whole module comes on a tray. Now, this airplane's not finished, so you see a couple of wires hanging here, but mostly it's very nicely, completely is nicely done. We don't have everything tied up yet because there are other systems that are going in. But as you can see, all the switches are organized Everything is strain relieved. The wiring bus is in there. It's also nicely organized, and overall a really nice job. We can also see the computer from here that runs the engine, and we can see the strain relief on the cable itself. That could also be done with ADAL clamps. Now that takes care of the installation of the Viking engine as far as the throttle cable, your wiring bus, the actual connections of the wiring bus to the airframe. You can just copy right off of our website in the wiring pages. It shows you where all the wires go, and it's very basic.
Does that look familiar?
Alternator installation. The alternator already comes pre-mounted to the Viking engine. What you see here is the part that the customer would then complete. Obviously the alternator is not wired to the airframe because the airframe is not shipped with the engine. That's your part. Now we're running from the wiring bus directly. There is a wire that says alternator. This alternator wire goes to the first spade on the alternator. There's two spade terminals on the back of the alternator. They form the shape of a capital letter T. The top of the T would then be for the alternator enable wire that comes from the Viking bus. You also want to add another wire to the other spade terminal while you're wiring this, and you route those wires alongside with the main charging cable that comes from the alternator, that you can also see is nicely done here with a washer and a lock nut using adhesive line shrink tubing and aircraft quality number 8 wire or cable. Very important as the cable leaves the alternator that it is not allowed to vibrate and break at the terminal. What we have done is we have provided not only one strain relief using the alternator attached screw that we remove, put an ADAL clamp on, and put a little bit of blue Loctite on and reinstall, but we've also provided a second one to keep vibration completely isolated away from this point down here in order for this to never fail. It's not about maybe failing in 10 years, it's about never failing. So we want to make sure that everything that we do is high quality work and is consistent with the philosophy that it will never break. Now what we've done is we've nicely organized those 3 wires into protective loom, and they run underneath the intake manifold, and all the wires run into the same pass-through in the firewall. Now the wire that is for the alternator light, which is the red one here, the one that goes to the bottom of, or the vertical post of a pretend capital T letter, runs up and into the aircraft, and it runs to the back side of this little LED warning light. This is going to be changed to a larger warning light from Grand Rapids Technologies. They have a really nice one. We do want this to be a large warning light, so we're going to update this. Be aware that if you use an LED, it is polarity sensitive. It will not light up unless the polarity goes through it in the correct way. The way this is wired is, let me show you the light from the other side. Again, it's going to be upgraded to a bigger one because having alternator warning is super important in an airplane that needs electricity to run. So now this light will light up when the ignition key is turned on. Why is that? It is because one side of the bulb is powered on the terminal of the ignition key that gets hot when you turn the key to the first click, which is where it would be when you're flying. So use your meter and find the terminal that is hot on the ignition key when you turn it on. That provides 12 volts to one side of this bulb. Now, obviously you can just follow our wiring diagrams and you will see this. I'm just explaining it in real life here. Now, the other side of the bulb, in order for it to light, it has to have 12 volts and it has to have ground. Now, the ground is provided by the alternator. Now, guess what? It is only provided by the alternator when the alternator is not working. It's like the older cars. You turn the ignition key on, the red light came on, When the car starts, the light goes out. That's the same feature here. The alternator will provide the ground for the bulb as long as it is not charging. As soon as the alternator starts turning, the engine is turning, the alternator is turning with the engine through the belt, the alternator will be charging if everything is normal, and the ground that the alternator provides here will be removed by the regulator in the alternator, and the light goes out and everything is good. So that covers the installation of the alternator other than the main power lead. The main power lead, as we said, comes from here. It goes here. All the wires are grouped together and protected. This is a power cable. All power cables, once they run next to the engine, need to be in nylon gray stripe loom, high temperature loom. Not the cheap stuff that you get at the auto parts store. You can get this at Waytech Wire or Del City Wire. It has a gray stripe. It's used for fire trucks and ambulances, and it is a split loom, and it will protect your wires even when it gets warm. The cable then runs, as we explained, it runs to the other side here, and it goes across. Everything goes across in one area. If you take an overview of this electrical system, you'll see that there's a path to it. All the wires leave the battery, and then they cross over to the engine in one location, and then the alternator is, as we saw over here. Now let's just focus on the alternator. The cable goes here, comes over here. Now, as you can see, the alternator fuse that is on the website in the wiring diagrams is located right here. It's a 60 amp fuse. Now, if you do want to have a shunt for the alternator, meaning something that will measure amperage in your airplane so you can actually see if the alternator is producing current or not, you can put the shunt in this alternator wire cable, meaning that you will have two items in the cable before the cable reaches the section of this section in between the solenoids that are the hot part that then charges either battery 1 or through the other one battery 2. Meaning that the cable that goes from the alternator and eventually ends up at the battery, one or the other, will have two items in line with it. One being the fuse and the other being the amp shunt. The amperage shunt would then, if you use it, we don't show it here, you would jump from here to the input of the amp to the shunt, and then exit from the shunt, and then to the alternator. And then on each side of the shunt, there will be a little wire that goes to your instrument, and that's what actually measures the voltage drop across the shunt in order to tell your instrumentation, as in the Viking View or your Dynon, what the amperage is. So, moving along, you are now through your shunt if you wanted one, and then you have your fuse, and then the alternator cable continues on, and it terminates, and this is easier to see on the wire diagrams, but basically what you have is you have a cable jumping from here to here, and that's the output of the solenoids, and that's the area that is distributed to the airframe, and also where the alternator charging will come in, so that when this one's closed, it charges a battery, or if this one's closed, it charges another battery. So it's the jumper between them. And that covers the alternator installation, other than, of course, studying the main cables that are associated with it on our website in the wiring diagram section. We're going to talk about the grounding of the Viking engine to your airframe. Very, very important. The engine will not run without proper grounding. Now, the system should be set up so that the engine can run either on battery A or battery B or battery primary, battery backup, whichever you want to call it, or with neither battery hooked up and just running off the alternator. So our grounding has to be planned out for that, so that it will continue to run. The engine has to have the fuel pumps running in order to run, which means both the positive and the negative of the fuel pumps have to reach the engine. As far as the negatives have to reach the engine, same with the computer. The grounding from the computer has to reach the engine if the batteries get disconnected for some reason. The main ground for the computer system of the engine is down in here. That is this bolt right here. You'll see that it has a strain relief clamp right here, and there's a secure bolt right there. And It is made that way so that there's no flexing between here and here, and all the wires that are grounded are securely done and won't come apart. Now, this has already been done by Viking, but I just wanted to point out to you that that is a very critical grounding location, so that you are aware of it. If you ever were to take your harness out, you have to make sure that when you put it back together, that all the hardware that goes with this, as far as the correct number of washers and so forth, and the strain relief is then put back in place, and that this has the proper torque. Now, back to the main grounding of the batteries as they're installed in the airframe. We are running two main number 6 cables that go directly to the battery posts. The negative battery post on the one battery, the negative battery post on the other battery. They run along here, they come together, they go through this little eyelet, and we do have them grounded, which is usually a no-no, but in the same location on the engine using the same fastener. However, is a very convenient location to do it, to ground it. They're not on top of each other, and we're using a aircraft grade number 4 bolt at the proper torque, so we know that the bolt is not going to fail on us. That's the most that's the basic or the most fundamental ground, or the heavy ground, in order to ground the engine using a number 6 cable. This number 6 cable is necessary only for the cranking of the engine. When the starter motor engages, you need a large grounding cable in order to support the large positive cable that runs to the starter. So that's the main reason for them. Now, once that's done, we also want to focus on grounding of the airframe and the electronics in the airplane and the computer and the fuel pumps and all this kind of stuff. So what we have done is, right in this area, we located a grounding bus, a purchased grounding bus. It is also grounded from several areas in order to have redundancy. We have one grounding wire coming in here. It originates from the engine itself, right down here, using a 6mm screw and a washer. And we're using a heavy-duty terminals on all these cables. Let me just mention that real quick. These terminals are much thicker than what you will find at an automotive store. They're heavy-duty lugs. They're meant for this purpose. They're about twice the thickness in material. They're like automotive quality, then there's regular quality, and then there's heavy-duty quality. And you want the heavy-duty quality. All terminals are crimped using a special crimping tool that are designed for it. Every single terminal has the right size for the bolt and the right size for the wire. You want to buy a whole bunch of them that have a 1/4-inch hole that goes for all the 6mm screws on the engine. You want a whole bunch of them that have 5/16 or 8mm hole that goes on all the big lugs on your contactors and so forth. And you want them assorted with either for number 6 or number 10 or number 8 cable. Now, back to our grounding. We covered the main grounds from there, and we're talking now about the grounding bus that we installed in the airplane, and that we're feeding a ground from the engine again, and it goes to the grounding bus. We are also supporting ground to this bus from the battery, right here. That is, if this cable for some reason came loose, we would have alternative ground from the battery. Everything has a backup. Now, we are then grounding the airframe through this little wire and a stud through the airframe itself, and that is grounding the internals of the airplane for the radios and electronics and so forth. And there's a grounding bus on the other side of the firewall that supports that, and there's many different kinds that are available. That covers the grounding bus input. We also have outputs from the grounding bus. As you can see in the back here, you see these, they're hard to see because they're all black. Those are grounds that are necessary for the engine to run. The fuel pumps are grounded there. Any kind of transducers are grounded there. Anything that's associated with making the engine run are grounded to this bus. And that covers the grounding system. You can also, of course, study, and you should study, the wiring diagram, and you'll find all this information as far as the layout of it on the main power distribution diagram of the Viking website. Okay, we're continuing on with the power distribution for the Viking engine. The most basic thing are 2 lithium-ion batteries, and these are the part numbers of them. LFX 24 Alpha 3-BS-12, or no dash, just BS12. As you can see, those are 24 amp batteries. They also make one that's a 36, actually that's the charge rate of 24 amps. They make another one that's 36, it's your choice. They're the same size, the other one's just more money. So if you live up north, maybe go with the 36. 24s also work just fine, but you'll have a little less capacity overall. Now, the first thing that happens is that you will physically mount the components. As you can see, and in the pictures that we're going to show on our website, this system uses a battery tray that was made on top of the engine. It was fastened to the firewall, a couple of screws, and fastened to the engine in the front. That's, by the way, the heater hose. And then we mounted the things that are necessary for the electrical systems to it. And so the batteries were mounted using some angle and a lock with a nut plate inside the airplane, a heavy-duty nut plate. And just happens to be that the airplane had these nice fences that the batteries fit in between, so side to side. Back to the, well, then we mounted the contactors. You need 2 of those from Aircraft Spruce and Specialties. And we mounted our fuse for the alternator, and we mounted our grounding block over there. So anything that you want to mount that's need to have heavy-duty battery cables running to and or from, you can mount here, and it enables you to get good strain relief to everything. As you can see, we have from, oh, by the way, just to cover these boots, you don't need boots on everything if you're careful, because the switches inside the airplane will turn your masters here, your contactors on and off. And if there's no power or grounding to this lug or this lug, meaning that the switches in the airplane are down, then a whole lot of this stuff is not, there's no power. The only thing that has power is the cable from the battery going to the input side of this contactor. By the way, the contactor will have a positive sign on there. It says BATT, battery. And also from the other battery. You see there's a boot on there. That's the positive side of that battery. That will be hot at all times, even with the switches off. So it has a boot on it. And that one goes to the input side of the other contactor, which also would say BATT, or battery. So that's all there is to bringing power to the 2 contactors. From there, it's very simple. It looks complicated, it might seem complicated, dual batteries and all that stuff, but it isn't, because all you're doing is bringing the power to the input side of each contactor from the battery, and then you just jump them together. And then the rest of it is now as though it was just a single battery, because everything here goes now to the airplane, and it's all as though there was one battery. You are just selecting if you want to bring power in from this side, or from this side, or from both sides if you want to use both batteries to start the engine, and then turn on one off or the other one off. So that's what you've got, and what we're going to do is cover the rest of the wiring in a second.